The assignment related to standing waves. We'll discuss from question 28 onwards. So the first question 28, state principle of superposition. What is the principle of superposition, or what superposition principle state? It states that if two or more waves combine with each other, meet each other, then the resultant wave, the amplitude or the displacement is of the resultant wave is equals to sum of individual displacements. So the idea is that when two or more waves meet each other or combine with each other, the resultant wave displacement is equal to the algebraic sum of the individual. So when the waves combine with each other, the resultant wave is equals to the algebraic sum. For example, if I say this is one wave and say it is having an amplitude 1 centimeter up, 1 centimeter down from the mean position. And another wave is there which is having an amplitude say 2 centimeter up, 2 centimeter down. But when these two waves will combine with each other, what will the resultant wave when they combine? Because crest is combining with the crest and the trough combined with the trough. So as a result, when these two waves combine with each other, the resultant wave will have a higher amplitude. So, and we call that as a constructive interference. Like they increase the effect of each other. But what if, like example, this was 1 centimeter and the other wave was 2 centimeter like this. Now, when these two waves will meet each other, the resultant is the algebraic sum of the two, but they try to cancel out each other. So not completely destructive, but yes, it is a destructive. So 1 centimeter and 2 centimeter. So the resultant wave will be 1 centimeter down. So this one result in a formation of a constructive interference. This one is a destructive. So when two waves combine with each other, the displacement of the resultant wave is equals to algebraic sum of the individual wave. Is it clear? The superposition principle?
Yes, sir, clear.
Okay. Then next question. Question 29. A student is investigating the physics of electric guitar. Guitar is a string instrument, so for finding the speed of the wave, we can use this formula V is equals to under root T divided by mu. This is valid for wave in a string, where T is the tension, the force on the string, and mu is the, you can say, a thickness or mass per unit length. Like how much mass is there in a unit length, that will give us value of mu. When a string on a guitar is plucked, a standing wave is produced with one antinode. So what does it mean? It means it is produced in this manner. Because as I mentioned, there's only one antinode. So there will be node, antinode, and node. So one antinode is there, which is there at the center. The student finds that the speed of the wave in a stretched string is given by this formula, where T is the tension in a string and mu is the mass per unit length, as I mentioned. The student decided to measure the diameter of a string and the frequency of fundamental node. Fundamental node means when it is vibrating in one loop, that is known as the first harmonic or fundamental frequency. She then constructs a spreadsheet to record these results and calculate the value of V, mu, and T for each of the string. The string is made from a material which is having mass per unit volume. Mass per unit volume, which we also say density, is given 7,800 kilogram per meter cube. Now, This is a spreadsheet, like the values which student completed. The first column, she's having length. The second one, frequency. The third one, speed. The fourth one, diameter, volume of 1 meter, mass per unit length, and then the tension. The formula to calculate the value of C3, cell C3 means like this is C, this is C, and this one is 3. So this is C3. How C3 is calculated? It is 2 multiplied by A3 multiplied by. Why this is the correct formula? So 2 multiplied by A3. What is A3? A3 is the length. A3 is the length and multiplied by B3 is the frequency. So 2 multiplied by length multiplied by frequency. The question is why this is a correct formula to calculate the speed. So what is the reason why this one is a correct formula to calculate the speed? Look, how we can justify this. We have the formula for any kind of wave. The wave equation is there, which is used that shows B equals F lambda. Or V is equals to lambda F. It's the same thing, no difference. Now, when, as I mentioned in the beginning of the question, that the string is vibrating in one loop. So when it is vibrating in one loop, near the fixed end, it is a node, and at the center, it is antinode. And this length is how much? L. So in terms of wavelength, if I want to say the distance between the two successive nodes, in terms of wavelength, what is this distance? Lambda, lambda by 2, lambda by 4. The distance between the two successive nodes from one node to another. How much is distance?
Lambda by 2.
Lambda by 2. So means from one node to another node, the distance is lambda by 2. So I can say the length of a string is equals to lambda by 2, or I can say that this 2 is divided, other side will be multiplied. So 2L is equals to lambda. So in place of lambda, I can say 2L. So V is equals to 2L multiplied by because in place of lambda, I substitute 2L. So V equal to L multiplied by frequency. What is 2L? 2L. So that gives the like, that's why it is valid. So it is 2. What is L? L is cell A and frequency cell, that is B3. So that's why the formula to calculate the cell C3 is equals to 2 multiplied by A3 multiplied by B3. So your answer here, you will mention that because the wavelength, the length is equals to, the total length of a string is equals to half of wavelength. So wavelength is equals to 2L. That's why V equal to L into F is used to calculate the speed of this wave. Is it clear that why this formula is used?
Yes, sir.
Any doubt?
No.
No.
Then write the formula to calculate cell E3. So first we'll check what is E3 and then we'll try to figure out the formula. What is cell E3? Cell E3 is basically volume of 1 meter length. So volume of 1 meter length, like here, we want to calculate this E3. So how I can calculate the volume of 1 meter length? So if I want to find volume, because this is a string or a wire. So using a diameter, first we can work out the area. How we can work out, because area multiplied by length, I'll get the volume. But I want to find the volume of 1 meter length. So L is equals to 1. So if I would need the volume, that is area multiplied by length. What about the area? I have the diameter. So area of cross section of a wire is pi d square by 4. So pi d square by 4 multiplied by L. And what is L here? Because I've already mentioned we want the volume of 1 meter length. So L is equals to 1. So if L is equals to 1, so volume will be equals to pi d square by 4. Means the diameter square multiplied by pi divided by 4 will give us the volume. And which diameter? Because as you can see, the diameter is different here. So which cell we should use? We should use cell D3. As they ask in the question that how we will work out E3. So for E3, which is a volume of 1 meter length, and the formula is pi d square by 4. So where d is the diameter. So which cell we'll use? So we should use D3. So it will be pi D3 square by 4. That will give us the volume of this spring, which is having a length 1 meter. Is it clear? It's one.
Yes.
Yes, sir.
If any question or a part you're not able to understand or you want me to repeat, just let me know so I will repeat that part. Then the next one, write the formula to calculate the value of cell F4. So first we have to identify what is F4. For F, what is F? F is a mass per unit length. So how much mass is there in a unit length? We'll get the value for the cell F4. Like this is F4. So mass per unit length. So we need the mass, and then we need the, because mass per unit length is there, so total mass divided by length will get this value. So how to work out the mass? If you check in the beginning of the question, they give us the density. In the beginning of the question, they give us the density, and we already worked out the volume. So I can find the mass. As we know, density is mass divided by volume. So mass will be density into volume. So using density into volume, I'll get the mass. And divided by the total length, the length is given here. Because mu is mass, this is actually mu, which is a mass per unit length. So mass divided by length, I will get mu. How to get the mass? That is density into volume. And how to get the length? That is there in the column. You can see the first column, the length is there. So we can use that length to work out. So what will be the formula? So in place of mass, it is density, which is 7,800 multiplied by the cell is there, the volume is there. How we work out the volume? So this was the volume. In this case, because we want to work out for F4. So F4 divided by length. But what length I will take? Because if you see here, we got the volume of 1 meter length. So length is 1. So here length is also 1. We don't need a column here. Why we don't need a column? Because we calculated the volume of a wire which is having a length of 1 meter. So length is 1 here again. So how to get the mu? So mu will be 7,800 multiplied by F4. So 7,800 multiplied by F4, we will get, sorry, multiplied by E4, not F4. Multiplied by E4, we will get this mu. Is it clear? Because the length is 1, that's why I did not use, and why I did not use this length, because these are length of 0.655, but we already calculated the volume for 1 meter length. That's why we did not use this length. We use if the length was 1 meter, what will be the volume? That's why we are using a length as 1 meter, not 0.655. Is it clear, this part?
Yes, sir. Clear.
Why using E4?
Why using E4? Because in the question, they ask us to calculate how F4 is calculated. Like this value is calculated. Cell F4. So to get cell F4, which is a mass per unit length. This is a cell F4, which is mass per unit length, or we can say mu. So mass per unit length, how to get the mass? We know the density multiplied by volume and divided by length. So if you check, this is a volume of 1 meter length. So this column is giving us the volume. So this is a volume column. So, and this cell is representing E4. So that's by E4. Multiplied by density is how much? 7,800. Divided by length, because that is the length of 1 meter. That's why it is divided by 1. So mu is equals to 7,800 multiplied by E4. Clear?
Yes.
If the same question was there, how F6 is calculated? This is F4. So in that case, it will be E6 is 7,800 multiplied by E6 will give us F6. Like this volume multiplied by 7,800, we will get. And you can see when I multiply this by 7,800, I'll get this as 0.78. Because it is minus 6 is there, like 0.1 exponent minus 6. Then we have to complete, hence calculate cell F3. How to calculate F3? How I'll get the value for F3? So what simply I have to do? E3 is there multiplied by 7,800. So 7,800 multiplied by E3, I'll get the mass per unit length, and in this case, it will be F3. So when we multiply these two, what's the answer? Look, remember the value is how much? It is 7,800 multiplied by 0.656 exponent minus 6. When you multiply, what's the answer? Our final answer should be 10 power minus 3. So 7,800 multiplied by 0.656 exponent minus 6.
5.1 into 10 to power negative 3.
So 5.12 into 10 to power minus 3. So minus 3 exponent is already there, so we don't have to write. We have to just write 5.12. Then the last part, calculate the cell, the value for G6. G6. We want to calculate this G6. What is G6? G6 is actually the tension. And how we can work out the tension? If you check in the beginning of the question, they give us the formula that speed of the wave is equals to under root T divided by mu. So if I need tension, so V is equals to under root T divided by mu. If I square equation both sides, so V square is equals to T divided by mu. Or V square multiplied by mu is equals to T. V square means the speed, because I want to calculate G6. So I need the speed for that only. So means I need C6. So C6 square, like the speed is square, multiplied by mass per unit length for that part, 0.78. But don't forget to use the, because the spreadsheet exponent minus 3 is written in the at the top at the column heading, but when you're substituting a value, you have to take full value. So what we need cell F6 to get this T. So C6 is how much? 324 square multiplied by F6 is how much? 0.78 into 10 power minus 3. So 0.78 into 10 power minus 3. Multiply, you will get the tension. What's the answer for this?
82.
82. So 82 Newton is the tension in this string. So that's how you complete this spreadsheet. In part B, the student decided to verify this equation by using one string. She removed a string from a guitar and clamped one end in a support, and she varies the tension by hanging the weights. The speed of a wave is calculated for the length of a string and measure the frequency of fundamental note when the string is plucked. Describe how student could use a graph to verify this equation. The student want to verify that this equation is correct. Student is varying the tension and calculating a frequency with reference to that. So we have this V is equals to under root T divided by mu. If I square this equation both sides, so it will become V square is equals to T divided by mu. Or if I rearrange equation, V square is equals to 1 over mu into T. Then we'll compare with the equation of straight line y is equals to mx. Like if student plot on y-axis, if student plot V square, on x-axis there is a tension. So what will be the gradient? The gradient of this line will be 1 over mu. So how student could use a graph to verify the equation? So student can plot a graph between, or it can be other way around, like without taking a square, student can also plot a graph between V and under root T. So V is equals to 1 over under root mu multiplied by under root T. It's the same equation, but I just separate the square root. And now student will compare y is equals to mx. On y-axis V and on x-axis under root T. So what will be the gradient? The gradient will be equal to 1 over under root mu. If this equation is valid, then the gradient should be 1 over under root. Or you can also square and V square over T. So gradient will be equal to 1 over mu. If this equation is valid, it will follow this like the shape of the graph, and the value of the gradient will be equal to reciprocal of mu. That's how we check different equations, whether they are dimensionally correct or no, like whether they are valid by plotting a graph of certain quantities. Question 13, the photograph shows a string instrument. When a string is plucked, progressive waves travel in both directions along the string, reflected at the end, and produce a standing wave. Figure 1.1 represents the standing wave on a string. Figure 1 is there. It can be shown graphically. This is a graphical representation. Suggest a suitable label for x and y axis. So what are the labels whenever for standing waves? So x is representing the distance and y is representing the displacement. So x is representing the x-axis, the distance, and y-axis representing the displacement. The wave undergo a phase change of pi radian or 180 when reflected at the end. How this produce node at A and C? Like what they mean here, because so these are the fixed end of the string. When the wave is traveling, the two waves which are traveling, when it strike, like when the waves strike the fixed end, it undergo a phase change of 180. Means if the trough strike, it will become crest. If the crest strike, it will become trough. So as you can see, two waves are 180 out of phase or pi radian out of phase. So how this will produce a node at A and C, like at point A and at point C, why there is a node always. So what is the reason for that? Because what happened, now the two waves will be anti-phase or out of phase by 180. So they will, when they interfere with each other, they cancel out the effect of each other. That's why it will produce antinodes. So two waves are 180 out of phase. Meet each other or combine with each other or interfere with each other. Which produce a destructive interference. Leads to formation of node. So always for the standing wave, whenever there's a standing wave, it is produced, it will always produce a node at the fixed ends, at the ends. Is it clear?
Yes, sir.
Yes.
Then a particular spring is there, which is having a length of 35 centimeter. State the wavelength of a wave when the vibrating in figure. So this length, this length is 35 centimeter. But whenever you're using the SI unit of a length is meters, it is 0.35 meter. This is a node, this is a node. What is the distance between the two successive nodes? How much? The distance between the two successive nodes in terms of wavelength.
Wavelength equals to the twice the length.
Yes.
Yeah. So that's right. Like the total distance in terms of wavelength is half. The distance between two successive nodes is half of wavelength, or we can also say wavelength is always twice of the length. So 2 multiplied by length, so length was 0.35. So when we multiply, it will be 0.7 meters. So as they ask the question, what is the wavelength here? That is equals to 0.7 meters. Then the string oscillating, the frequency is given. We already worked out the wavelength, so we can use the formula V equals F lambda. Frequency is 196 and lambda is 0.7. But like, as I mentioned, very common mistake students used to make, they forget to convert the unit like they use it and write 70 centimeter. Because if you use 70 centimeter here, your final answer for speed will be wrong. Because SI unit of a speed is meter per second. So either you should write meter per second, or if you don't convert, then centimeter per second will be the final answer. So you multiply, you will get this as 137 meter per second. Then question 31, a vibration generator vibrates vertically, as you can see, and it creates standing wave. How it creates standing wave? The vibration generator, basically, it is sending the wave. Two waves are traveling in opposite direction. But what are the two waves? The one wave which is going up and another one is strike and coming down. So two waves combined with each other, they give rise to a standing wave. So two progressive wave, and they've mentioned the position X, which is marked where the coil are stationary. What does it mean stationary? It means they cancel out the effect of each other or nodes are formed. Photograph 2 shows a section of a spring. The coils at a position which are marked Y look blurred because the coils are in motion, like they're moving. Or what is why the wave in photograph 2 must be longitudinal? So what is the meaning of a longitudinal wave? Definition of a longitudinal wave: the particles are vibrating parallel to the direction of the wave. That's why we call that as longitudinal. So vibration parallel to direction of wave. That's why we call that as a longitudinal. So 1 mark is for mentioning that the vibration is in the same axis or parallel, and 2nd mark is for mentioning direction to the wave. The position marked X are nodes. What is meant by the nodes? How we define the term nodes? You have to learn. Node is the point where zero amplitude or displacement is always zero. So point where amplitude is zero or displacement is zero, we can also say nodes. And point where amplitude is maximum, we call that as antinode. How the standing waves produce? Again, this is a very common question. So, regarding the standing wave, how it is produced. So two traveling waves or two progressive wave or two waves, two progressive wave traveling in opposite direction meet or superimpose or interfere with each other, give rise to standing wave. So when two waves are there, traveling in opposite direction, superimposed, give rise to standing wave, produce nodes and antinodes. So there will be nodes and antinodes. Then the photograph of a standing wave, which is have the frequency of the wave is there, which is 34, and the velocity is 5. So we have to show that the velocity is about 5 meters per second. The photograph one. So how we can show? First, we have to find the wavelength, and to get the wavelength, we have to check how many waves are there. So photograph one. Look, as they mentioned, this is node. This is node, node, node. And we know distance between the 3 successive nodes equal to wavelength. So because 2 successive is half wavelength, 3 successive is 1 wavelength. So this is 1 wavelength. This is the 2nd wavelength, 3rd wavelength, 4th wavelength, and 5th wavelength. So there are approximately 5 wavelengths are there. And the distance, the length of 5 wavelengths is how much? 72 centimeter, but it should be in meters, so 0.72 meters. So wavelength is equals to 0.72 divided by 5. So 0.72 divided by 5, which is about 0.14 meter. And then we need the speed. So speed is frequency multiplied by wavelength. The frequency was given in the question, and the wavelength is 0.14. When we multiply, we'll get the speed, which is about 4.8 meter per second. Is it clear? Discussion how we work out the speed of the wave in a string, which is producing standing waves.
Yes, sir.
Yes.
Then the velocity of the longitudinal wave in a string is also determined by finding the time for a pulse to travel along the length of a string. So that is called a pulse echo technique. Like we send the wave and then the wave will return back. The spring is spun while the pulse is created from the bottom and allowed to reflect from the top. The pulse travel up and down 21 times. Show that the velocity of a longitudinal wave spring determined by this method is also about 5. The time taken for a pulse and the length is given. Basically, what we did, we sent the wave and 21 times, like we received 21 times. So here, the total 21 times. So this is sending and receiving one time. That is one, then till 21 times. And the total time is given for that duration. But whenever there's a reflection, speed is 2 multiplied by distance divided by time. So we will first find, because this is for 21 times. So V is equals to 2D divided by T. So 2 multiplied by distance, which is 0.72, and divided by time. But that is the time for 21 reflection, like we're going, coming back, 1, 2, 3. So this time will divide by 21. So this will be 6.17 divided by 21. And why it is 2D, why not only D? Because the wave is sent and then it receive or bounce back. That's why it is not only distance, it is multiplied by 2. So this will also give about 4.9 meter per second. And the last part, the vibration generator is then turned sideways so that the vibration horizontally, the photograph 3 was taken, frequency 14, and the length of a string is 72. Compare the pattern of a photograph 1 and photograph 3. Photograph 1, as you can see here, photograph 1 and photograph 3. So what is the main difference? The main difference is the type of the wave which is produced. Like, first thing, both are producing a standing wave, and this is also nodes and antinodes are there. As you can see, this is a node, and antinode. Then node, antinode. So when we compare the patterns, first thing, the similarity, both are producing the standing waves. But what are the differences? The number of the wavelength, the first figure we already calculated, it was producing 5 wavelengths. But here in the second figure, how many wavelengths are there? How many wavelengths? This is one wavelength and this is another. So 2 wavelengths. So smaller, shorter wavelengths are there. So both are producing a standing wave. Both have nodes at the end you can compare. And when you compare they will have the same velocity as well. Same velocity will be there when we calculate. But the differences will be, one is producing 5 wavelengths and another one is producing only 2 wavelengths. And another difference was, the first figure, the direction of the particle vibration was parallel, but here it is perpendicular. Is it clear, this comparison between photograph 1 and 3? Any doubt in this?
Yes. No.